If we have a lot of data and a lot of different values, we can present this data in a nice summarized form using a grouped frequency table. Here's an example. So here's a set of data that, let's read it up here. Certain kinds of tumors tend to recur. The following data represent the lengths of time in months for a tumor to recur after chemotherapy. So you have chemotherapy, the tumor's gone, and then this is the number of months it takes for that tumor to recur. So when I count this, I come up with 41 pieces of data. So I'm going to write that like this. I'm going to use a small n, a lowercase n. That's always going to represent the sample size. So our sample size here is 41. Here's how we're going to do this. Here's how we're going to make the table. So we are going to group the data into classes. Now you can see here, this problem is asking us to use 5 classes. We'll see how to get that. But we're going to group the data into classes. And then what we want is that each class should have the same width. We'll talk about that as we do it. And each piece of data has to belong to exactly one class. So let's talk about how to get the number of classes. Now generally there's going to be between 5 and 15 classes. If you have fewer than 5, you could probably use an ungrouped frequency table. And if you have more than 15, you just need to make your classes a little bit wider so that more data can fit into each class. If you have more than 15, it gets hard to look at. So let's talk about how to get the number of classes. So generally, we know we want between 5 and 15, so you can pick any number that you like between 5 and 15, inclusive 5 and 15. But here's a general rule of thumb that you might want to use. If you have a calculator, it makes it easy. So I'm going to write a formula here. This is called Sturges Rule, and in the formula there's going to be an N and a C. And N is going to be the number of pieces of data that you have. In our case it was, 41. And C, that's going to be the number of classes that you might use. So here's what we've got. C, the number of classes, is equal to 3.3 times the logarithm. Now don't worry about that. Your calculator will do that. The log of N plus 1. Okay, this is Sturges Rule, and it just gives you an estimate for the number of classes you could use for your data set. So if n equal to 41, here's what we'll get. C, an approximate number of classes, is 3.3 times the logarithm of 41, logarithm base 10, and then plus 1. Now, this is, here's how we're going to do this. So how about if we just do this? On your calculator, you type in 3.3, then you press the logarithm key. Now on the TI-84, which is the one that's in common use, the log key is on the very left column, like 4 up from the bottom. So you press the log key, and when you do that, you get a set of parentheses. You type in 41, and then you have to close that parentheses. Now that right parentheses is right above the 9 on the TI-84, and then plus 1. Okay, so when I did this, it came out to 6.532 ... all right? So here's what we have. So C is about 6.5. So we could use maybe, what could we use here? We could use 6 or 7 classes. However, what we're asked to do in this problem here, they've just chosen 5 classes. All right, so what we're going to do is we'll use 5 because we'll do it the way that they're asking us. So we will use 5 classes. Here's how we're going to get the class width. Pretty straightforward. We're going to take the largest data value, so we have to look through our data and find out the biggest number. And then we're going to subtract the smallest data value, so as we're looking, we'll look for the smallest value. We'll take that difference and then divide it by the desired number of classes. So let's see, what we're going to do here is, you know what, we need to go back. I'm going to go back to the data and look for the biggest and smallest values. Now here's how I might get the smallest one. Okay, I'm going to scan through the data. Well, right away, I can see a 1. All right, so that's the smallest value, a 1. Now to get the biggest value, I mean, it's kind of hard to look through all this data, but here's what you might do. Just go down to columns, pick out the biggest number, like 38, and then move over and see if you can get a bigger one. 38, Now 45 is the biggest. Now 59 is the biggest. Still 59 is the biggest. 59 still. 59 still. And as I scan them, nothing is bigger than 59. So I think 59 is the biggest value. Is that right? Yeah, 59 is the biggest value. 1 is the smallest value. So let's get back over to our formula here. The largest value turned out to be 59. So we will get a 59 out of here. Minus a 1 divided by, now they've got us using 5 classes, right? So what we're going to get is, what do you get here? 58 divided by 5. And in my calculator, that's 11.6. Now I'm going to round this up. I'm going to say that this is going to be rounded up to 12. So I think what we'll do is use a class width of 12. Now I'm going to make a table here, and this table is going to have probably more than you would typically need, but let's just make a complete table so that everything shows up. So here's what I'm going to write here. I'm going to have the class limits, class boundaries, and we'll talk about that as we go. And then we'll have the midpoint. Now I'm just going to call that X. We're going to have the frequency. How about if we call that F? And then we'll have, all right, we'll talk about these as we go through. This will be the relative frequency. And this will be the cumulative frequency. Now, generally, what you might just want to do is, in yours, or a typical one, you might have class limits or class boundaries, and just the midpoint or just the frequency. So a really brief version would be class limits and frequency. But we're going to put everything in here just so that we can demonstrate anything that you might need. Now, let's get these. So the class limits. Well, we said we're going to use a class of, that's a width. Use a width of 12. All right, so here's what we're going to do. We're going to start at the smallest one, and I want 12 pieces of data to go in here. So 1, 2, 3, you know, this is going to go 1 to 12, and then what? 13. Now, I want 12, so you're counting 13. So this is going to, if I just added 12, I'd get 25, but I'm counting 13, so this is going to be up to 24, right? Count it. 13, 14, 15, 16, 17, 18, 19, 20, 21, 2. Okay, we get 12. And then we're going to go 25. Now, if I add 12, I'd get 37, but I'm including 25, so I only get to 36. And then the next one would be 37, and then 49, but back it off one because we're counting that 37. And then 49, all right, this would take us up to 61, but back it off one to 60. All right, so we've got every piece included, right? The smallest one, the smallest number was the 1. That'll go into the first class. The biggest number was 59. That'll go into this class. Now here's the class boundaries. You can see, we're going to use boundaries because you can see there's a gap here. There's a gap of 1 unit. Right now there's nothing in that, but it does leave a gap. So we want to fill in that gap. And here's how we can do that. We're going to take the lower, down here at the bottom left, we're going to take the lower class limit, subtract 0.5, and then we'll take the upper class limit and add 0.5, right? So we're going to subtract a half, add a half. So like in the first one up here, the class boundary would be what? It's going to be 1 minus 0.5, and then the upper class limit would be 12 plus 0.5. So we're going to get what? 0.5 up through 12.5. All right, so let's write those. So we're going to go from, say, 0.5 to 12.5, and you can get these pretty easily. Now, 13 minus a half is 12.5, and that matches this one, right? So those two classes just touch each other there, to just back up to each other. And then we're going to get up to 24, plus the 0.5 is 24 and a half. Okay, 24.5 minus, Okay, 36.5, right, adding that half. 36.5 to 48.5, and then 48.5 all the way up to 60 and a half more. Okay. Next thing that comes up is the midpoint. This is a class midpoint. Right, so to get the class midpoint, what we want is the middle of each class. So what we're going to do is, how do you get the middle of these two values? It's just the average. So you're going to add the lower and the upper limits together, and then divide by 2. Right, so you're going to take the lower class limit, add the upper class limit, divide by 2. So let's write these here. This is going to be, in the first one, this is going to be 1 plus 12 over 2. We get 13 over 2, which is 6.5. So I'll write a 6.5 up here. Now you might want to do just the next one, but you'll see what happens here. The next class is what? This one here. 13 and 24. So we are going to get, when we add these, we'll get 13 plus 24 over 2, which is 37 over 2, which is 18.5, so I'll write that in here, 18.5. Now, you don't have to do this computations for the other ones. Look what happens. 6.5, how far up to 18.5? 18.2. 18.2, 18.5. What did I write there? 18.5. Okay, I'll get it. How far from 6.5 to 18.5? Well, that just happens to be our class width. So if you add 12 to this, what do we get here now? 18 and 12, well, that's a 30, right? So we're going to be here at 30.5. Add 12 to that, we're at 42.5. And add 12 to that, we're at 54.5. Now let's talk about how to get these frequencies. So we're kind of out of room on this page. So we want to talk about the frequencies. So I'm going to go to a new page. I'll bring the data set up, and then we'll show you how to tally these things up. But as we do this, you can see there's a lot of work here already. But as we do this, we're not really going to be doing this by hand. We have machines that do this for us, and we have software packages that do it for us. All we have to put in is the data and the number of classes that we want, and either the calculator, the TI-84, or a piece of software will do all this for us. But we're doing this so that we really have a good understanding of what's going on, then we're able to read it better and get more information. So what I've done here is I just brought back the data set, and I've written this little table down here. Here's my class limits. Now I'm going to tally this, and this is a count. Easy for things to go wrong here, at least for me, because I miss some numbers sometime. But I'm going to do this by, you can either count through the columns or the rows. I'm just going to go down the columns. So what have we got here? Okay, I'm going to count the number of pieces of data in each class. So what are we going to have here? So 19. Now 19 belongs, right, that 19 belongs in this class right here. So I'm going to give that a mark of 1. All right, so I'm going to put a tally mark of 1. Now, the next piece of data is this 50. All right, so where does 50 belong? Well, 50, right, so that 50, that's going to go down here. So I'll give that a tally of 1. Then the next piece of data is this 14. Now the 14, that's going to belong in this class right here. So I'll give that a tally of 1. Let's just do a few more. And then I'll get the 38. Now the 38 belongs where? That's in this class right here. So that'll get a tally of 1. And then we've got a 27. Now the 27 belongs here. So we'll get a tally of 1 there. Okay, so I'm not going to do this for all of these. It just make you crazy if I just sit here and do all these. So I'm just going to tally them up, and then I'm going to write them down, and then I'll come back and just show you the final tally. So I'm done counting. In fact, I did it twice, which was a bit tedious. But here you can see what we've got. In this first class here, from 1 to 12 inclusive, we've got 6 pieces of data, right? 1, 2, 3, 4, and then you draw that line for 5, 6. So I've got 6 pieces of data in the first class. 5, 10 in the second class, 5, and then 13, and 8. So that is how you make a tally. So let's go back to our last page. We were actually constructing our table. And here's what we've got, right? So I'm going to come over here to frequency. So I tallied those up. And now what I got was, what was it? It was 6 here, and then 10 here. I think I had 5, 13, and 8. So what we're saying is, remember what this is the number of months it takes for a tumor to recur. So, like, what did we have? Between 1 and 12 months, say in the first year, there were 6 cases. Between, say, in year 2, there were 10 cases, and so on. Okay, now let's get to relative frequency. So the relative frequency, okay, before I jump into relative frequency, just run a quick check. If you add these numbers up, the frequencies, if I add these up, 16, 21, and 21 is 42. Right, now what I'm getting is 42, and now it occurs to me all the way back at the beginning. I'll take us there. Look what I wrote here. I wrote 41 because I miscounted. I've got 1, 2, 3, 4 rows of 10 and 2 more. It's not 41, it's 42. You probably caught that up at the beginning and wondering what I was doing, but I caught it. Okay, so it's nice to run that quick check. So my check does work. I'm at 42 pieces of data. Now let's get to relative frequency. So relative frequency means this: relative to the entire set of data, relative to all 42 pieces of data, how often does the 6 occur? Well, 6 divided by 42. All right, so in the first class, what I'm going to have is, I'll just do it down here. So for the first class, it's going to be 6 divided by 42, and I get 0.1428 ... I'm going to round this off to just 2 decimal places. Right, that's about what? 14% of the time. So I'm just going to write these as decimals. So 6 divided by 42 is 0.14. So that's 6. The first class appears 14% of the time. The next class would be 10 out of that 42. And if I make that division, that comes out to, I'm going to round off to 0.24. All right, so this is 0.24. Then 5 divided by 42 comes out to 0.12. 13 divided by 24 comes out to 0.13. I'm doing this on my calculator. And 8 divided by 32 comes out to 0.19. Now, that should up, if I added up these numbers, here, it should come out to 1, 100%. But remember, I rounded off, so this may not come out to 1. In fact, what do you get here? 8, 10, and 12, right? It doesn't come out to 1. That's because we rounded off. One last column here. This is accumulative frequency. This tells us kind of how fast things are accumulating. So just accumulate. Now accumulate, we're just going to add. So here's how you do this. It's accumulative frequency. Take the frequency. Now, as you run over here on the left, say you're at the bottom of this class and you run through it, right? 1, 2, 3, 4, 5, up to 12. If you run through that class, how many pieces of data have you encountered all together since the beginning? Well, 6. All right, so this is going to be a 6. So as I start from my lowest value, increasing to my highest value, I've run through 6 pieces of data as I go through that first class. Then as I go through this next class here, as I go through this class, I've encountered what? 10 more pieces of data. So by the time I go from 1 all the way up through 24, we have accounted for, I'll do it down here at the bottom over here on the right, 6 plus 10, I've encountered 16 pieces of data. And then in the third, by the time I get through that third class, right, I've gone 6 in the first, 10 more here, so 16. Now how many more here? Once we're through that class, we've encountered, what, 5 more. So now we're here at 21, right? That's going to be the 16 plus the 5, 21. Okay, and then what do we have here? You can just do this here. What's 21, and then we'll get through 13. All right, so 13, that's going to be a 34. right? So we'll have encountered 34 pieces of data, and by the time we're at the end, 34 and that 8, there's 42. There's all 42 pieces of data that we have encountered.